Ioannis told me that Ioannis told me that you haven't covered space security yet. So what I will try to do is to provide an overview of the most important aspects related to space security. So I'll give you some historical background, especially in the context of the militarization and the weaponization of space, a few things about how this was at play during the Cold War, and then we will briefly consider the space programs of China, India, Japan, and some dimensions in the context of the so-called Asian space race, not least because I assume that most students don't have this sort of background. And when we talk about space, usually we don't think about um, space powers beyond the United States and Russia, although now, of course, China is discussed in the news. I will also make then a few points about the emerging future of space security and what I found are some of the most challenging dimensions. So to begin with, a number of interrelated emerging challenges have generated a renewed interest in the international politics of space and space security. These include, but are not limited to, the following: the increasing militarization and even weaponization of space, and I'll say a few more things about this distinction later on, especially in light of Donald Trump's administration's establishment of the Space Force, the George W. Bush's administration's plans for the deployment of space-based missile defense systems, China's 2007 anti-satellite test, India's 2019 anti-satellite test, and Russia's anti-satellite test in November 2021. Other challenges include the US-China rivalry in space, the institutional deadlock on space arms control, the spread of space debris, the Asian space race, particularly between China and India, the issues of frequency interference, space traffic management, and space situational awareness. As space becomes increasingly crowded, and the regulation of the limited spectrum of radio frequencies and orbital slots, and of course, the long-term sustainability of space activities. More recently, by the way, the provision of satellite images of Russian troops in Ukraine and the use of Starlink terminals in Ukraine point to the blurring of the distinction between the private and public realms, as well as between military and civilian uses in space. So in some ways, we have entered uncharted territory here. Now, indeed, going back to the idea of space transforming into a more congested, contested, and competitive domain, which is a reference or term used by US military officials, there are now more than 70 countries involved in space activities, of course, including Greece. And the total number of operating satellites now has reached 5,465, of which 3,433 are operated by the United States. And it's also worth noting here that largely this number reflects the satellites launched by Elon Musk and SpaceX. We also, it's important to highlight that China has been operating 541 satellites. If you're interested in this data, the best source is the Union of Concerned Scientists. They have this dedicated site where they update regularly their database. However, allow me also here to make some points as a sort of providing a background before we move on with the military uses of space. It is important to emphasize that outer space is not as outer as we usually think. What we refer as outer space begins roughly 1 kilometer above our heads, and the bulk of space activities takes place in three main orbits: the low Earth orbit, the medium Earth orbit, and the geostationary orbit. The geostationary orbit is called as such because a spacecraft in this orbit appears to an observer on Earth to be stationary in the sky, And this is because satellites in geo are traveling at exactly the same rate as Earth. And those are very useful, especially for communication purposes. So if you have 3 satellites with a global coverage, essentially you cover the whole of Earth. Medium Earth orbits have been used mainly for GPS, and low Earth orbit are usually applied to Earth observation. What is interesting, though, is that not only is Earth gravity a key feature of these orbits, but the large majority of space operations are Earth-oriented. In this way, it makes more sense to see this geographical area as an extension of Earth, both in political and physical terms. So in many ways, it's more like an extension of terrestrial politics and geopolitics than a separate or outer or something very outer. In fact, space is closer than Thessaloniki is to Athens. Now, a few things about space debris as well, although I know that some of your visiting lecturers, we have discussed that or will discuss that later on. Now, significantly, some analysts believe that space debris in orbit is so much that we are already reaching a turning point known as the Kessler syndrome or collisional cascading, named after NASA scientist Donald Kessler. In this regard, the density of objects due to space debris is high enough that collisions between objects could cause a cascade in which collision generates space debris, which in turn increases the likelihood of further collisions. This is important because the distribution of debris in orbit can render space activities and the use of satellites difficult. Given that in certain orbits, space debris can stay in orbit for many years, this can also mean losing access to space for many generations and returning to the pre-space age without global position systems, weather satellites, space-based communications, and satellite internet, just to name a few prominent space technology applications on which our modern societies depend on. Now, space debris is very important when we talk about space security, not least because the problem of space debris is compounded by the conduct of anti-satellite tests. Here I have a list of the most recent important anti-satellite tests. The 2007 anti-satellite test conducted by China took place at an altitude of 863 kilometers, producing more than 3,000 pieces of space debris that will stay in orbit for many decades. 1 year later, the United States conducted a test that was at a fair low altitude of 240 kilometers and generated orbital debris that decayed approximately 1 year later. The high altitude of those anti-satellite tests, the more space debris remains in orbit for decades. Then this was followed in 2019 by India's anti-satellite test, and the most recent one was by Russia, which was carried out at an altitude of about 480 kilometers, creating over 1,500 pieces of trackable debris that will remain in orbit for a long time as well. In terms of space weapon types, we can distinguish between destructive and non-destructive. The destructive ones can be kinetic tests, like the 4 anti-satellite tests I mentioned 1 minute ago. Those are essentially, you launch a rocket or a missile, if you like, that shuts down one of your own satellites, and it does so by the kinetic energy that produced by this contact. There are kinetic and non-kinetic Earth-to-space weapons, like projectiles or jammers, dazzlers, and cyber attacks. Kinetic and non-kinetic space-to-space weapons, such as on-orbit projectiles or microwaves, and kinetic and non-kinetic space-to-Earth weapons, like jammers, lasers, or projectiles that come down from orbit. Now, regarding the military uses of space, there is a consensus among analysts that the militarization of space began with the launching of the first communication satellites. Military and national security considerations provided a strong rationale for the development of the US and Soviet space programs during the Cold War. But the point to emphasize here is that the space race between the two superpowers during the Cold War was also an arms race, originating from the need to acquire highly accurate intercontinental ballistic missiles. It is also in this context that the use of space satellites was utilized to support critical elements of military operations such as surveillance, reconnaissance, early warning, and targeting that served as the foundation of the US and Soviet deterrence policies during the Cold War. And I'll say a few more things about this because I think it's very important and it has also important implications from where we are today. So in fact, not only did the two superpowers develop and deploy anti-satellite weapons, but they also detonated nuclear weapons in high altitudes at the beginning of the space age. This is a photo of Starfish Prime in 1962 and the electromagnetic pulse that was caused, electronic damage in Hawaii. That was so strong that even some traffic lights in Hawaii went blind because of that. So that's again important to keep in mind because the idea of space warfare was there from the beginning of the space age. However, a number of factors led to the reevaluation of these projects. In addition to high financial costs and technology deficiencies, it is clear that the specific qualities of the space environment posed unexpected dangers and risks that constrained the deployment of certain technologies, such as nuclear weapons in space and the use of anti-satellite weapons. Through tests and experiments, both superpowers realized that the space environment could not contain the emitted nuclear radiation in the space environment, putting human spaceflight, communications satellites, and reconnaissance satellites in jeopardy. Space debris generated by the conduct of anti-satellite tests during this period also highlighted the existence of mutual interdependence in the space environment. In other words, if you would go to use this sort of weapons in space, this didn't prevent from space debris or electromagnetic pulse to interfere with your own satellites and, damaging your own satellites as well. Now, crucially, this led to the emergence of cooperative restraint that defined the interaction between the United States and the Soviet Union since the early 1960s. It was in this context that the two superpowers decided to treat carefully to avoid destabilizing their relations, as they were aware of any move in space that could possibly distort the crucial relationship between the use of satellites and nuclear weapons. Consequently, the United States and the Soviet Union came gradually to mutually recognize the use of space as a collective good. This logic was reflected in the bilateral arms control agreements, which were signed between the two superpowers during the Cold War, which acknowledged the use of non-interference of satellites as national technical means of verification. And I'll say a few more things in a bit, but the whole idea then was that as part of these arms control treaties, as you might know, for example, the Americans will show their nuclear warheads to the Soviets through the use of satellites and the other way around in terms of verifying their nuclear agreements. This process was also manifested in the formation of the legal regime that still guides the multiple activities in space, more on which below. The point to make is that although the two superpowers used space for military purposes, they did not deploy actual weapons in space. Now, notably, while there was not a clear and authoritative definition of the term peaceful uses in the United Nations documents and treaties, the widely accepted interpretation of the term peaceful in relation to outer space is non-aggressive instead of non-military. The legal regime of space contains important prohibitions concerning military activities, but at the same time it leaves open the option for the use of conventional weapons or the use of anti-satellite weapons, the transit of nuclear weapons through space, or the launch of nuclear weapons from Earth into space to reach an incoming missile. So although the term peaceful uses in relation to space has been accepted to mean non-aggressive, problematic here has been the distinction between the militarization and the weaponization of space. Although a definition of a space weapon is highly contested, generally it can refer to any specialized destructive device built to operate or take effect from Earth to space, space to space, and space to Earth. In addition, we are also seeing the broadening of what we understand as space security in terms of the concept. Sorry? Oh, I think I heard something.
Sorry, by mistake, I opened the microphone, sorry.
Okay, no worries. So speaking about space security, we are seeing the broadening of the agenda. Now the concept of space security embraces a broad understanding of the requirements of freedom of access to and use of space by all states. And according to some scholars, we have now a three-dimensional definition. Outer space for security, that is the use of space systems for security and defense purposes. Security in outer space, how to protect space assets and systems against natural and all human threats or risks and ensure a sustainable development of space activities. And security from outer space, how to protect human life and on Earth. It's also useful here to highlight that satellites are systems of four distinct elements: the orbiting satellite itself, the ground stations that control it, and the uplink and downlink communication channels that enable it to carry out its appropriate functions. And that's, I think, important because, again, when we talk about space security, we think about outer space, but the terrestrial elements would be under the greatest threat in wartime. Ground space facilities are crucial, as it is the atmospheric airspace through which electronic signals travel to and from satellites in orbit, that known as the electromagnetic lines. So instead of just trying to shut down a satellite, it might be in fact cheaper just to target the terrestrial components of those satellites. So again, we're entering into a sort of uncharted territory here, not least because this hasn't happened again. And of course, think now that with intersection of space security and the cyber domain, this is becoming more sort of a reality, right? What happens if you try to attack, target those ground systems through cyber attacks, for example, not to mention, of course, attacking satellites through cyber attacks, which has already happened. There have been a few cases when some satellites have been hacked. However, now we are talking about a shift from the militarization to the weaponization of space. There have been many developments that serve to highlight that. We are seeing during the 1990s a shift from the use of space assets in support of strategic deterrence to space utilization as a military force multiplier that involved enhancing the effectiveness of combat forces on the ground. Typifying this was the first Gulf War in 1991, known also as the first Space War. And that was because we saw for the first time the frequent use of space systems in warfare at both the operational and tactical levels. And that was largely thanks to the use of the GPS. At the same time, there was a further shift with the George W. Bush administration's plans to pursue and develop certain technologies that would signal the move towards the weaponization of space. And this was accompanied by a series of US doctrines and documents that called for the development of space weapons and control in space. In this slide, I also highlight a few other developments that pointed towards this direction. In 2002, the Bush administration announced the withdrawal of the United States from the Anti-Ballistic Missile Treaty, known also as the ABMT, which meant that no international treaty obligations existed anymore for the United States to refrain from moving forward with missile defense and space-based missile defenses. Then there was a lot of discussion and many references to the concept of space superiority that was reflected in key US military doctrines. So there was this prevailing discourse of the inevitability of conflict in space. Now, moving on to the regime for space activities, as far as space law is concerned, the realm of space is governed by 5 international treaties. In addition to the 5 treaties, the space regime comprises a set of 5 declarations and principles and a number of bilateral disarmament and arms control agreements between the United States and the former Soviet Union in line with international law and practices. I won't bother you too much with many details here, but it is important to stress that the Outer Space Treaty remains arguably the cornerstone of international order in space, largely because it introduces a series of principles and concepts that have since been regarded as the basic framework of international space law. Specifically, the Outer Space Treaty recognizes the common interest of all humankind in the progress of the exploration and use of outer space for peaceful purposes, and that the exploration and use of outer space, including the moon and other celestial bodies, shall be carried out for the benefit and in the interests of all countries, irrespective of their degree of economic or scientific development, and shall be the province of all humankind. So quite inspiring and inspirational overtones there. It also acknowledges that outer space is not subject to national appropriation by claim of sovereignty, by means of use or occupation, or by any other means, and prohibits the placement of nuclear weapons or other weapons of mass destruction in orbit or on other celestial bodies. Now, briefly stated, the fundamental principles then governing space activities include the concept that space should be reserved for the benefit and in the interests of all humankind and for peaceful purposes, and that it cannot be appropriated. In other words, that it is non-appropriable. As far as diplomacy is concerned, the United Nations system has been used as the main forum for space cooperation from the early days of the space age. After the launch of Sputnik by the Soviet Union, the United Nations General Assembly established the Committee on the Peaceful Use of Outer Space, known as COPUOS, in Vienna. And significantly, COPUOS has played a fundamental role in the evolution of the legal framework that governs space activities and has promoted the use of space applications by developing countries. Indeed, COPUOS has been the primary forum for the elaboration and development of the 5 international treaties and agreements that thereafter govern the realm of outer space. Beyond COPUOS, it should be added that the UN Conference on Disarmament, known also as the CD in Geneva, has been the single forum for negotiating space arms control. In 1981, the UN General Assembly adopted the Resolution on Prevention of an Arms Race in Outer Space, known as PAROS, which was put on the agenda of the Conference of Disarmament in 1982. An ad hoc committee was established in 1985 as a result on negotiating PAROS on the basis of consensus. From 1985 to 1994, the ad hoc committee held several meetings, but the process reached an impasse largely because of the US refusal to enter in such negotiations. In fact, as a result largely of the United States' position that there is no arms race in space and that there is no need for new treaties or agreements concerning space arms control, negotiations held at the Conference of Disarmament have been stalemate since the late 1990s. Now, having examined some of the features and challenges related to the space regime, we can now turn to consider the key aspects of China's space program, which is also part of my area of research. However, before doing so, it is important to briefly introduce you to the concept of techno-nationalism, which offers, I think, a useful analytical lens through which to make sense of China's space programs. A few points are worth making here about techno-nationalism. First, in his important book, Rich Nation, Strong Army, National Security and the Technological Transformation of Japan, Richard Samuels has defined techno-nationalism as the belief that technology is a fundamental element in national security, that it must be indigenized, diffused, and nurtured in order to make a nation rich and strong. He also emphasizes that Japan's techno-nationalist ideology as a set of ideas and beliefs has been highly contested and very plastic, but its endurance and relevance can be explained because its value has been renewed continuously across time. This is useful because it helps to capture the ideological basis of Japanese strategic thinking about the role of technology in linking national security with economic development. It also serves to highlight that the term should not be a misnomer for associating technological capabilities merely with nationalism or prestige considerations. My understanding of the term, however, and this builds on an article I published in the Review of International Studies, although accepts the crucial elements of competition, it also focuses attention on how highly visible projects, such as space programs, are parts of recognition games which states play in order to acquire the status of a great power. In doing so, my formulation of the term also calls attention to the role of technological advancement as an informal standard of modernity and hierarchy in international society. Significantly, the origins of Chinese techno-nationalism can be traced in the 19th century, when technological advancement emerged as a standard of civilization that differentiated the society of civilized states from non-European societies. Indeed, technology was increasingly seen as a measure of the level of civilization in the 19th century, embedded in a techno-scientific orientalist discourse, what I have called techno-scientific orientalism, which contributed to the construction of hierarchical conceptions of modern science and technology. This process has had a powerful and enduring influence on Chinese and Indian conceptions about science and technology. Therefore, my formulation of techno-nationalism emphasizes the importance of China and India's colonial experience as a major factor in shaping an influential view about the role of technological achievements among Chinese and Indian policymakers that resonates until today. In other words, space technology, along with other high visible technological achievements, can be used to indicate the state's power, statehood, and great power status. And the Chinese and the Indians, because of their experience of seen as uncivilized in terms of their technological advancement in the 19th century, they still place a lot of emphasis on space or also nuclear technology as a way to demonstrate their participation in modernity and as a way to indicate their arrival as great powers in international society. And again, I can elaborate a bit more on that, but I think it's very important to have this historical perspective in order to understand why China and India emphasize a lot their achievements in space. Now, moving on, the rise of China as a major space power has been one of the most widely noted features of the current politics of space. In some ways, China's early interest in pursuing a space program was influenced by the same military, political, and prestige considerations that shaped the space programs of the United States and the Soviet Union. By the way, China has one of the oldest space programs that can be traced back to at least the mid-1950s. So, like the first two participants in the space age, China's initial space endeavor can be seen as a reflection of the realization that building space capabilities would enhance military effectiveness and improve China's international political prestige during the Cold War. Like the United States and the Soviet Union, China's space program also benefited largely from ballistic missile development, which was driven by its nuclear program. Yet, despite the fact that a case of China may not appear to be quite distinctive in this respect, it is also important to note that the context and evolution of the Chinese space program was rather unique, not least because China, when compared with the United States and the Soviet Union, was not only a relatively backward state in terms of its economy and technology, but also went through periods of sustained political and social turmoil during the Maoist era. Under such circumstances, a key puzzle is how China's space program succeeded. In addressing this question in my research, I have argued that China's space effort from its inception, and I would say until today, has been especially marked by a techno-nationalist ideology in a post-colonial context. Indeed, the history and evolution of space development in China might have been different were it not for techno-nationalism as a composite and complex but influential ideology that rendered the pursuit of space projects appealing to China's political and scientific elite as a normative indicator of the state's scientific prowess, great power status, and modernity. Nevertheless, it is possible to identify four phases of China's space program. It is Chen Shuisen, known as the father of China's space program. Notably, Mao gets much of the credit for China's decision to develop its first satellite soon after the launch of Sputnik in October 1957. Yet although it is clear that Mao was a prime mover of China's space effort, it is unlikely that such a scientific and technological effort would have come to conceptualization were it not for the support of China's scientific community. And indeed, by January 1958, even before Mao's proclamation, Chen Shuisen and his colleagues had initiated the draft of a satellite development program and appointed a working group under the code name Project 581. In addition, other key figures that played a key role in the promotion of China's space program were Premier Chu Enlai and Marcel Nie, who successfully articulated an influential techno-nationalist vision that shaped the pursuit of China's strategic weapons program, including the space program. Now, the second phase of the space program coincides with the decade of the Cultural Revolution, that's between 1966 and 1976. Despite the fact that the Cultural Revolution engulfed the entire Chinese society, this period also saw China joining the Space Club, with the successful launch of its first satellite in 1970, which was followed by other space feats. This was made possible thanks to the efforts by Chu Enlai and Marcel Nie, who protected key scientists and engineers involved in the missile and space programs from the excesses of this highly politically charged period. What is more, this period also saw a continuing interest in human spaceflight. That's a rather quite well-known aspect of China's space program. In fact, in the early 1970s, a group of 20 astronauts were selected for a 2-year training program as part of Project 774. However, domestic political considerations associated with factional strife led Mao to cancel China's human spaceflight ambitions by famously saying, "We should take care of affairs here on Earth first and deal with extraterrestrial matters a little later." Now, Mao died in 1976, and after a short succession struggle, Deng Xiaoping consolidated his power and took China in a startlingly different direction by initiating his policy of reform and opening up. And this marked the third phase of China's space activities in the post-Mao era from 1976 to 1989. Consequently, China's space program moved towards a focus on economic development, including the development of communications and meteorological satellites. However, a turning point was the 863 High Technology Plan, which was initiated by 4 senior scientists, and the plan suggested the development of dual-use technology with an emphasis on civilian applications along techno-nationalist lines. The 863 program focused on 7 technological fields where China should attempt to follow international developments, decrease the gap between China and more advanced nations, and look for advantages where China could make a breakthrough. These were automation, biotechnology, energy, information technology, lasers, new materials, and space technology. And it's very important to highlight that because there is a lot of hype now about the achievements of China in space and how fast they are and so on. But these projects go back to the 1980s, right? So that's something to keep in mind in terms of strategic planning when it comes to space. Thus, despite the fact that this period was marked by Deng's emphasis on few space projects that could contribute to economic modernization, such as communication and meteorological satellites, the techno-nationalist vision enshrined in the 863 high-tech plan provided a new impetus for the space program, including human spaceflight. Of equal significance, this period also heralded China's engagement with the global space community more generally. And by the way, this is a 1987 Chinese poster that reads "Our past, present, and future." Now, since then, China has pursued its space program with a noteworthy consistency. It has also sustained a comprehensive approach towards the exploitation and exploration of space that encompasses the full spectrum of space activities. Not surprisingly, human spaceflight and space exploration have attracted much global attention. China's most remarkable achievement during this period was the implementation of the human spaceflight project that was approved in 1992, designated Project 921. To this end, the Party Central Committee established the Human Spaceflight Project Office under the Central Special Committee, tasked with the coordination and implementation of the Human Spaceflight Project. Now, importantly, the Central Special Committee is an ad hoc high-level decision-making committee consisted of senior, civilian, and military leaders, including the Premier, Defense Minister, and leading scientists, which is responsible for the supervision of the more significant strategic technology projects. The fact that the 921 project was overseen by this committee meant that the much-needed political authority existed to help transcend bureaucratic hierarchies and inertia. Eventually, the first successful human spaceflight mission carried out in October 2003, and this made China only the 3rd country in the world after the Soviet Union and the United States to put a human in space. And since then, China has successfully launched other human space flights, and of course, very recently, it has completed its space station. And Xi Jinping, China's president, has also made many references to the space dream as part of China's dream. And again, I can elaborate a bit more on that, but I hope it's very clear to you how politics are very much related to these developments. Another important development here, just to briefly highlight, was China's first Mars mission. In 2020, China conducted its first lunar sample return mission. I mentioned the completion of China's space station. And in 2020, China also completed its equivalent of GPS, which is aimed at providing global coverage. At the same time, important progress has been made in the use of space for military purposes. The lack of transparency in China's military policies and the inherent dual use of space technology make any accurate observation about China's military space capabilities a very difficult task, of course. But here again, I highlight some of China's military space capabilities. There is a focus on the development of dual-use satellites for communications, reconnaissance, navigation, meteorology, electronic intelligence, and signals intelligence collection. The Chinese, as like the Americans and many Europeans, the Indians and the Japanese, see space as a force multiplier. And space is also has been designated as commanding height in international strategic competition in China's latest defense white paper. There is also a growing emphasis on counter space capabilities. As I mentioned earlier, China conducted its first anti-satellite test in 2007. It also has anti-satellite capabilities. And there has been a great focus and a great interest in taking advantage of new technologies, and this was reflected in the creation of the People Liberations Army, a new organizational structure, the People's Liberations Army Strategic Support Force, with the aim to combine the operation of the space, cyber, and the electromagnetic domains in a more centralized and effective way at the strategic level. However, as far as the notion of an Asian space race is concerned, although there has been much hype in the media, it is more accurate to say that China's space program in general is moving at its own pace, driven by its perceived national interests rather than the actions of other states. At the same time, and I won't say much, just being cautious of time, but I can elaborate a bit more in the Q&A session. At the same time, India is also emerging as a great power in space. Like China's space program, India's space program goes back to the mid-1950s with the establishment of India's national space program. This took a more institutional form in 1969 with the formation of the Indian Space Research Organization, known as ISRO. India launched its first satellite, Aryabhata, in 1975, and since then it has been developing a focus, many space-based assets with a focus on socioeconomic development, including the development of launch vehicles and communications and remote sensing satellites. At the same time, and despite this priority on the use of space for socioeconomic development, we are seeing over the last years a shift in India's focus from the use of space for socioeconomic purposes to space exploration and other space activities that can point to a more interest in gaining international prestige. In 2008, India successfully launched its first mission to the moon. In 2014, India became the first Asian state that reached Mars. That was ahead of China. In 2018, Prime Minister Narendra Modi announced India's plans for a human spaceflight mission. And interestingly enough, as I mentioned before, in 2019, India conducted its first anti-satellite test. Meanwhile, Japan is also another important actor in space. Again, Japan has one of the oldest space programs that can go back at least to the Diet Resolution of 1969, which defined Japan's space program exclusively for peaceful purposes, and that was related, of course, to Japan's military past. And again, I highlight here some very important developments in Japan's space program. Interestingly, and as a result to concerns about Japan's as a response to China's growing military space power, we are also seeing the militarization of Japan's space program as a sort of a balancing against China's space capabilities. It should also be noted that space can be an important source of soft power, economic opportunities, and a powerful diplomatic tool in China's bid, for example, for regional and global leadership. For example, in recent years, China has established and increased space contacts with a number of Asian countries, including Pakistan, the Philippines, Laos, Sri Lanka, Thailand, and others. And notably, space technology is an important part of China's Belt and Road Initiative. In 2014, it was also reported that China aims to construct a Belt and Road Space Information Corridor, and 2 years later, a government white paper on the Beidou navigation satellite system stated that in line with the Belt and Road Initiative, China would build satellite navigation augmentation systems with affiliate economies. As far as India is concerned, it should be noted that in June 2014, Modi proposed the development of a satellite to be used by the member countries of the South Asian Association for Regional Cooperation, known as SAARC, with the aim to provide a full range of applications and services to all our neighbors as a gift from India. And with the exception of Pakistan, that decided not to participate in the project, the other SAARC members, Afghanistan, Bangladesh, Bhutan, Nepal, the Maldives, and Sri Lanka, welcome India's initiative. Eventually, in May 2017, India successfully launched the so-called South Asia satellite, which will offer services to the region, such as telecommunications and broadcasting applications, including telemedicine, teleeducation, and disaster management support. The satellite generally has been hailed by pundits and experts and the media as an indication of India's growing recognition that its advanced space program can be used as a foreign policy tool, which can serve to enhance its regional leverage, especially with regards to its relations with neighboring countries. But remarkably, the South Asia Satellite Initiative has been largely a response to the perceived growing presence of China in South Asia, characterized by Beijing's effort to strengthen space cooperation with New Delhi's neighboring countries in what India traditionally views as its own sphere of influence. So what should be added is that Japan has also stepped up its diplomatic efforts as a way to counterbalance China's influence. For example, it announced recently plans to expand space ties with Malaysia. So that's important because we're seeing now the use of space as part of competition between especially China and India for regional leadership, and the use of space as a source of influence that goes beyond military capabilities, and essentially as a source of soft power. As far as Asia-Pacific regional multilateralism in space is concerned, China has been active in the promotion of regionalism with the establishment of the Asia-Pacific Space Cooperation Organization, known as APSCO, that started officially operating in 2008. And with its headquarters in Beijing, the Asia-Pacific Space Cooperation Organization consists of 8 member states. In addition to China, those are Bangladesh, Iran, Mongolia, Pakistan, Peru, Thailand, and Turkey. Characterized by a formal organizational structure, the organization's aims include the promotion of multilateral cooperation in space science and technology with an emphasis on development and research, space technology application and training of space experts, and so on. In 2015, the organization issued the Beijing Declaration, focused on improving space capacity building in the Asia-Pacific. So briefly stated, the creation of the Asia-Pacific Space Cooperation Organization clearly indicates China's desire to establish itself as a space leader in the Asia-Pacific. Meanwhile, Japan has been leading the Asia-Pacific Regional Space Agency Forum, a more informal institution that is voluntary and solution-driven, involving both state and non-state actors from over 40 countries, with the goal of promoting and expanding peaceful uses of space activities in the region. In addition, it should be mentioned that India is hosting the UN-affiliated Center for Space and Science Technology Education in Asia and Pacific, which supports education programs focused on the use of space technology for social and economic development. In this context, some observers see the existence of two regional space institutions as a manifestation of competition for regional leadership, as I mentioned before, a sort of, if you like, contested multilateralism in space, shaped by broader geopolitical, economic, and political considerations. Now, there is also evidence to suggest that a sort of balancing has been taking place in recent years in the context of the US-China rivalry. But while much attention has been paid, and rightly so, to the relations between the United States and China as a possible expression of balancing behavior, there is also some evidence that balancing may have a regional dimension. In fact, as we have seen, the 2007 Chinese anti-satellite test has had the effect of prompting India to accelerate the development of its military space capabilities, which has been exacerbated by the increasing space cooperation between China and Pakistan. The notion of an Asian space race, especially between China and India, is also suggestive of some sort of soft balancing. And another example here is Japan's increasing interest in the military uses of space, which, as I mentioned before, is partly a response to China. To be sure, this regional dimension is compounded by the series of bilateral security relationships that the United States has formed with its close allies in the Asia-Pacific, known as the hub and spoke system. Crucially, a space component has become more prominent in the US alliance relationships as part of the US pivot or rebalancing to Asia. For example, in recent years, the United States and Japan have taken key steps towards expanding their military cooperation in the domain of space as part of their comprehensive dialogue on space and the 2015 revised US-Japan defense guidelines. Several areas of military space cooperation have been identified, including space situational awareness and maritime surveillance from space. At the same time, the United States has also extended its space cooperation with Australia and South Korea with an initiative on tackling space debris. Part of this process is also increasing space cooperation between the United States and India, both in civilian and military terms. In parallel with the deepening of space cooperation between New Delhi and Washington, space ties have been established between India and key US allies in the Asia-Pacific. This has been evident in India's expanding space ties with Japan, Australia, and South Korea. Now, taking stock of these developments, the picture that emerges is dynamic and mixed, defined by elements of cooperation and competition, reflecting broader regional dynamics that are worth being familiar with. Seen against this backdrop, it is possible to argue that the so-called Asian space race is more of a media hype, but some competition exists in what can be seen as multiple races, for example, between the United States and China, China and India, and China and Japan. And complicating this is the existence of variations of competition and cooperation based on the issue area. For example, whether it is commercial or regional leadership, as I mentioned before, military or civilian, and so on. Now, a few things about US-China space relations. The first thing to mention is that space relations between the two countries is almost non-existent, and this is because of the Wolf Amendment. Which was introduced in 2011 by an American congressman with the same name, which prohibits essentially NASA working with China unless there is approval from the US Congress. There was strategic dialogue with China under Obama, but this is not taking place anymore in light of the broader strategic climate at the moment. And in fact, there is a lot of mistrust, and I would argue that a security dilemma is unfolding already, whereby both China and the United States are assuming the worst case scenarios and bad intentions on the other side. However, and it's very important to keep that, again, some historical perspective here. If the United States and the Soviet Union managed their relations and even cooperated, albeit to a certain extent, in space, why not the United States and China? Given how important space is and how the recent strategic climate, in fact, can lead to destabilizing space. And of course, we also talk about two nuclear powers at the same time. So there is clearly the need for guardrails and for strategic dialogue. And this would involve, of course, for both the United States and China to assume great power managerial roles, that is, trying to find a framework for coexisting in space, not least because their impact on the space security of everybody else involved is very, very important, as space becomes important for not only a growing number of states, but also for a growing number of non-state actors, and of course, given that we all depend on the use of space for our daily lives. So just to sum up, I briefly discussed the new challenges to space security by highlighting the importance of space debris. We've also considered briefly this shift from the militarization of space to the weaponization of space, how the military uses of space were very important during the Cold War, but how this was also characterized by what we saw as strategic restraint. We've also considered briefly the broadening of the space security agenda and the regime complex for space activities characterized by new actors and processes. Space is clearly not a vacuum, right? There are many laws, regulations, and also tacit understandings and norms about governing space, but at the same time, so many challenges exist. And based on my research, I also wanted to highlight a few things about China's, India's, and Japan's space programs, not least because I remember that when I was a student, there wasn't much focus on Asia, and now, of course, Asia is the most important geopolitical region in the world. And in the context of discussing briefly the future of space security, it's inevitable not to say something about US-China relations. I believe that the future course remains unwritten, but space great powers should assume great power responsibilities by contributing to stabilizing space. And I would leave it there for now, just to also leave some time for discussion if there are any questions.
Dr. Strikos, we would like to thank you for your insightful lecture. Θα συνεχίσω στην ελληνική. Να πω ότι ήταν μεγάλη μας χαρά και τιμή που σας είχαμε εδώ. Θα σημειώσω ότι ανάμεσα στους φοιτητές που παρακολουθούν σήμερα υπάρχουν και σπουδαστές της Ανώτατης Διακλαδικής Σχολής Πολέμου. Οπότε εκτιμώ ότι θα έχει και ιδιαίτερο ενδιαφέρον λόγω αντικειμένου και για εκείνους η σημερινή διάλεξη. Ήταν μια πολύ χρήσιμη προοπτική στα μαθήματα που έχουμε κάνει μέχρι τώρα, διότι τα περισσότερα κινούνταν γύρω κυρίως από ζητήματα ρύθμισης διαστημικών τεχνολογιών ή χρήσεων του διαστήματος, και σήμερα είδαμε μια πολύ ενδιαφέρουσα πτυχή. Μας παρουσιάσατε με έναν εξαιρετικό τρόπο τις πολιτικές διαστάσεις που μπορεί να έχουν οι χρήσεις του διαστήματος και κυρίως ό,τι αφορά τις διεθνείς σχέσεις και τα ζητήματα ασφάλειας που εμπίπτουν ενδεχομένως σε αυτό το αντικείμενο. Και σαφέστατα το τελευταίο μέρος δηλαδή της παρουσίασης, το οποίο αναλύσατε αυτές τις σχέσεις που αναπτύσσονται στην Ασία σχετικά με το διάστημα, ήταν πάρα πολύ καινούριο και πολύ χρήσιμο, διότι βλέπουμε ότι όντως η Ασία αποτελεί μια περιοχή που συγκεντρώνει το ενδιαφέρον παγκοσμίως πλέον, τόσο σε θέματα οικονομίας όσο και ασφάλειας και άμυνας, και διαπιστώνουμε και νέες πρωτοβουλίες, όπως κάποιες από αυτές εμπλέκουν και την Αυστραλία στα θέματα ασφάλειας εκεί περιφερειακά. Ήταν νομίζω εξαιρετικά ενδιαφέρον. Θα παρότρινα τους σπουδαστές σήμερα, αν έχουν κάποια ερώτηση, είναι μεγάλη ευκαιρία να την διατυπώσουν τώρα. Αν κάποια θέματα από αυτά που αναπτύχθηκαν σήμερα παρουσιάζουν έτσι ένα ενδιαφέρον ενδεχομένως και για διπλωματική εργασία, θα ήταν πολύ έτσι μεγάλη ευκαιρία να τα δούμε.
Δύο τινά μπορώ να φανταστώ. Ή ήταν πολύ βαρετά αυτά που είπα, ή είστε πολύ ντροπαλοί. Δεν υπάρχει κάποια άλλη εξήγηση.
Κυρίως το δεύτερο, είναι λίγο φιδωλοί οι φοιτητές, αλλά τώρα έχετε και την ευκαιρία, επειδή οι προηγούμενες διαλέξεις περισσότερες ήταν στην αγγλική γλώσσα, μπορείτε τουλάχιστον να διατυπώσετε, αν θέλετε, στην ελληνική την ερώτηση και ο κύριος Στρίχος θα σας απαντήσει ανάλογα. Είτε να διατυπώσετε στο chat.
Ωραία. Αφού δεν υπάρχουν ερωτήσεις, έχω εγώ να σας κάνω πολλές ερωτήσεις.
Βεβαίως.
Γενικά, δεν ξέρω τώρα, το background είναι δημοσιογραφία και...
Το τμήμα το μεταπτυχιακό είναι διατμηματικό, από το τμήμα νομικής και δημοσιογραφίας και μέσω του μαζικής επικοινωνίας. Ωστόσο, παρακολουθούν και φοιτητές από άλλα επιστημονικά αντικείμενα, κυρίως από το χώρο των θετικών επιστημών, μαθηματικών, φυσικής, της επιστήμης των μηχανικών και οι σπουδαστές της ΑΔΙΣΠΟ. Υπάρχει μία ερώτηση στο chat, αν θέλετε να σας τη διατυπώσω, αν δεν την βλέπετε.
Ναι, μακριά από
ναι,
προβλέψεις. Μακριά από προβλέψεις. Έχουν γίνει πολλές σημαντικές εξελίξεις σχετικά με την Ευρωπαϊκή Ένωση. Ανακοινώθηκε για πρώτη φορά το European Space Defense Strategy, που είναι κάτι καινούριο. Αυτό ήρθε μετά, νομίζω ήταν το 2019, που ανακοινώθηκε και ένα Cyber Strategy. Γίνονται πάρα πολλά πράγματα στο διάστημα, υπάρχει και πολύ ενδιαφέρον σε επίπεδο regions. Υπάρχουν, για παράδειγμα, και στις Βρυξέλλες οργανισμοί που προωθούν τη χρήση του διαστήματος, κυρίως το Κοπέρνικους, για περιφέρειες στην Ευρώπη. Τώρα δεν ξέρω άμα ηχογραφείτε, άμα σταματήσετε την ηχογράφηση μπορώ να μιλήσω και πιο άνετα.
Ωραία, ναι, μπορούμε εδώ να σταματήσουμε.